So this is K, 2K, 3K. So I want to replace this with an equivalent spring constant. So first of all, how these two are? These two are parallel. The effective of this will become in series with this one. So the equivalent spring constant will be 2K and 3K. So how much it should be? 6K by 5 according to the formula. Then this is K and this is the block. How these two are now?
Sir, if
Uh,
it is in parallel, we should add them also.
so sorry, yeah,
5K.
parallel. Yeah, sorry, this one. This will be 5K. Yeah. 2K plus 3K, this will be 5K. Now, how these two are. So I'll call this as a some A something. That A is here. Now these two are, they are in series. So the effective spring constant now will be 5K and K. 5K, so this will be 5 by 6K. Like this, many set of springs will come. So how to replace them? There's a one series parallel method what we'll apply. So you can ask questions. Why you are doing like this? See here, working with this will be really troublesome. If one spring I'm very comfortable. Therefore, I'll take help of series parallel to check whether like a what is the displacement of block. Now I can easily analyze the motion of the block here, no, than this one. That's why we are bringing this method. That's the only purpose. Okay, now you do get a situation where this is K, this is 2K. This pulley is light. I want the effective spring constant of the system. Effective spring constant of the system. So what we should do? We have to replace. We have to find out the equivalent spring constant. Are they series or parallel? They are nor series nor parallel. No? So you may get a situation of this kind also. They are nor series nor parallel. Then what method we have to apply? So what you do is like let the displacement of block be x. You pull down the block by x. Then let this spring be elongated by x1. Let this spring be elongated by the x2. We can compare like this. Is it okay? No. So assume that only spring 2k is there. Then if the block moves by x, let it be elongated by x1. Then or it's the what is the method? I'll pull the block by a distance x. Then this both the springs will get elongated. Let the elongation be x1 and x2. We don't know how much. Let's assume that x1 and x2. I'm assuming that one. I think it's quite natural. If I pull the block by distance x, then what happened to the springs? They'll get elongated. Let the elongation in individual in the respective springs be x1 and x2. Okay, let's come for how x, x1, x2 are related. So I'll take help of superposition principle. X is equal to. Let's assume that only spring 1, spring 2k is there. Then assume that this spring is not there. Assume that one. If the block moves by 1 meter down, how much this spring will elongate? 1 meter. Is that okay? Assume that this spring is not there. Just as the one wire is there. Then if the block moves by 1 meter, then how much this will move up? How much spring will elongate? By 1 meter. So therefore, what is x is equal to? X is equal to x1. Then assume that now this spring not there. Assume that the spring K and the block is there. If I move this point on a pulley by 1 meter, then how much block will move? By 2 meter, constraint equation. So what is the displacement of block X? twice the displacement, the elongation of this spring. I am asking you to come to constant equation. If I move a point on a pulley by 1 meter, here 1 meter will become loose. The block will move down by how much? 2 meters. So what is the displacement of block? Twice the elongation of this spring. So here, this I'll write it as 2x2. Okay, let's come for spring forces. How much of spring force is elongated, no? So how much of spring force here kx2 will act. Then how much of spring force will act should act here? 2k x1. And then pulley is light. The same spring force should act here only. 2k x1. So if you want the spring is elongated, no? So therefore, how the spring force should act at this particular point. So what is this? All of you able to get this? Spring is elongated. So how the spring what spring is elongated. So what spring force will do? Will act. Yeah, it should be like this. 2k, because only this everything is a spring. So this spring force, what happened? It's elongated, no? So here shall I write like this? Those who are getting confusion how to show forces, I'm showing in detail. Why, sir, you are showing like this? Is it justifying? What is the state of both the springs? Both the springs got elongated. So if you want to write information, elongated.
Sir, can you explain again why 2x2?
Constant equation, if the pulley P moves by 1 meter, assume that the spring is not there. If this moves by 1 meter, here 1 meter will become loose. This will move by 2 meters. If this point,
Yes, sir, understood.
if this moves by 1 meter, this will elongate by 1 meter, no? But this block will move by 2 meters. So there's a constant equation I'm bringing. Okay, now let me equate the forces. So what is the net force on the pulley? Pulley is massless. So net force should be equal to 0. Pulley is massless, so therefore kx2 should be equal to 2 into 2k x1. So what is x2 equal to? 4x1. There's a relationship between, so there's equation 1, there's equation 2. Let's come for, I'll replace x1 or x2, I'll replace here. Put 2 in 1, x equal to x1 plus 2 into x2 is how much? 4x1. So x is equal to x1 plus 8x1. So x1 equal to x by 8.
Sir, x by 9.
X by 9. I'll substitute this value of x1 here. So this will become 4x by 9. So if you displace a block by x, what will happen to the springs? Like they will have displacement x by 9 and 4x by 9. Huh? If x is the displacement of block, so what is the displacement of the other two springs will be given this much. So are they, if they are in series, what would happen? If they are in series or something. So can you say anything about series parallel? No, they are not series, not parallel. Springs are not series, not parallel. Sir, how do I come to know? I think looking at the diagram, because one pulley has come because of that, they are not series, not parallel. So whenever, so you get a situation where they are not series, not parallel. So we have to use this method to find out what is the elongation in each spring. What is the elongation in each spring? So this is about the basic idea about how to calculate elongation in each spring. So what was the question I asked? So can you replace them by one equivalent spring? Can we replace them with an equivalent spring? Yeah, that we can do it, but we have to take help of the SHM condition. So that is not advisable to teach the topics of that. So time being, I'm just telling what will be the displacement of individual like elongation individual springs. So if you have SHM idea, there what happen? We'll replace these two springs by an equivalent spring constant. I have to find out the time period of the block. From there, I have to get an expression for that. So that will be, I think, a lot of burden for a student. So I'll try to avoid. So any of you, if you know SHM, you can continue. Since most of you might have not have depth of concept of SHM, no, I'll just stop it here. With the SHM, what happened? We can find out equivalent spring constant. Time being, I'll I'll stop it here only. If you take some Pathfinder, some books, no, they are asking questions of like this, where you need further concepts, which we have to enter into SSM chapter. Simple harmonic motion, some around 6 hours, we have to do discussion, then we can conclude here. But in exams, they may ask you something, find the elongation of the springs. Okay, got this. So I can bring any number of springs and I can test, if I display the block by a certain distance, then what is the elongation in other part of string. So this is the method what you have to apply it. Okay, let's come for some. Okay, all of you read the question. This from Pathfinder, we brought it.